Okay, in this video we are going to talk about negative impedance. And we will use an op-amp to simulate some negative behavior of an impedance, like a negative resistance or something similar. Let me first clarify what I mean by negative impedance. Suppose I have a voltage source with two terminals, one of them grounded. Let me call these two terminals as plus and minus. And suppose I take a piece of resistance and one of its terminal is again grounded, the other terminal is here. Now if I connect these two terminals like this, then there will be some current flowing from left to right if this end is positive and this end is negative, and if this voltage is V and if this resistance is R, then Ohm's law says that this current I should be equal to V by R, and if this value of this voltage is positive, that means if this terminal is positive and this terminal is negative, then this current, which is from left to right, will be positive. And if this V is negative, then current will be from right to left, or in other words, the value of this current I will be negative. Okay, so essentially here the impedance or resistance in this case is V by I, and this number is a positive number, R is a positive number, because when this terminal is positive, according to my chosen sense or direction of current, this current from left to right will be positive. If this V is negative, then the current will be from right to left, or the current I will be negative. Now if I could have made an arrangement which behaves as follows, where I have this voltage source once again with two terminals, one terminal is grounded, and I call this one as minus, the other one is plus. So that's my chosen reference for the voltage. And let me have some arrangement, I don't know how to make it, but say this has a terminal, it can have another terminal which is grounded, and when I connect these two terminals, and let me choose the sense or direction for current in this branch from left to right, so I is from left to right, V is said to be positive when the upper terminal is at a higher potential than the lower terminal. So these are my conventions. Now if I can make a situation, I mean somehow in this is a black box, I don't know what is there inside, but if I can mix a box such that when this V is positive, current is from right to left, and when V is negative, I or current is from left to right. So this arrangement then I can call as a negative resistance, because it's behaving in a manner opposite to or contrary to the Ohm's law. When this potential is higher, current instead of flowing from left to right is flowing out from right to left. So then I will call this arrangement as a negative resistance. Okay, so that's what I mean by a negative resistance. When this terminal is positive, instead of current flowing from left to right, actually current flows from right to left. Or I will say this current from left to right is negative. When this is positive, if this V is positive, then this current which is left to right is negative. Okay, if I can make such a box, such an arrangement, I'll call this as an negative resistance. Okay, now let's see how can we do that. Let's see the philosophy, how can we do that. Definitely this is not going to be a ohmic resistance like this, so that this cannot be a piece of metal or piece of graphite or any conductor, because in that case, if we use any passive element like that, any piece of metal, conductor or such things, then definitely when this potential is positive, current must flow from left to right. That's what physics says, that's what Ohm's law says. So this should be a more complicated arrangement than just a piece of metal. And the scheme that I'm going to use is as follows. What I will do, I will have an amplifier. Okay. And then suppose here is the input voltage source V with two terminals, plus and minus. Okay, so this goes to the input of the amplifier, and say for now let me take that the gain of this amplifier is 2. So if the input is V, then the output will be 2V. Now what I will do, I will connect this with a piece of resistance, and the other end will be connected to 2V, right? So this is the scheme I'm going to use to simulate this negative resistance. I hope you already have guessed what is going to happen. Let me still say what's going to happen. When this voltage is V, I'll have V here, that means V here, but this amplifier amplifies this voltage, and I have 2V, double voltage on the right side, which comes here. Therefore I have 2V here and V here, so definitely the current must flow from right to left in this resistance, and this current will come through this branch and come like this, assuming that infinite input impedance for the amplifier. So by this, what I mean is that no current can go inside, nothing can come outside of this amplifier, like an op-amp. If you have studied op-amp, you know that op-amp's input terminals allow no current to flow inside or no current to flow out of the input terminals. So this entire current, this amount, if this is R, then this current is definitely from right to left, and the amount is 2V minus V by R, which is equal to V by R from right to left. So this current comes from right to left, which is V by R. And if I had chosen the sense of current in a normal usual direction, which is from left to right, so this current from left to right, let me write it like this, left to right is actually minus V by R. and right to left is, so this is right to left is plus V by R, that means left to right is minus V by R. So you possibly have understood this scheme, that this amplifier is actually amplifying the input voltage and forcing with the double amount of voltage or an amplified amount of voltage from the opposite direction, and that's why instead of current flowing out of this external source, the current is actually flowing from this amplifier to the source. So this is what negative resistance is.